Hello everyone. In this video, we are going to test our code base that we have prepared for our logic assignment. Namely, it is our Logic Parser, which also have DIMACS support. First of all, let us test the optionality 1. Here, we are going to input an infix formula and the code is going to convert it into prefix. Let us test it. We choose choice 1 and we enter an infix formula. Okay, so I have to copy it. So we take an infix formula, a very long one, and we paste it here. So the code converts that infix formula into a prefix one. We can also build a tree from a provided prefix formula. So we take this prefix and we choose option number 2. We paste the prefix and the code converts that prefix into the tree. We can display the infix from the tree also. We choose simply option number 3 for it and the code converts the tree into the infix. We can calculate the height of the tree, which comes out to be 7 in this case. We can also evaluate the formula, which is option number 5. For that, we'll have to input a particular assignment for each variable. That is, we have to define an interpretation for this formula. Let us define one. And this is the last one. For these particular assignments, the formula evaluates to be true. Now, we can also convert the formula that we had input in option number 1 to a CNF formula. Let us do that. This is the CNF. Do we want to save the CNF file? The code asks. Yes. We can also check the validity of the CNF. The CNF is not valid. We can also convert the CNF into DIMACS. This is the DIMACS form of the CNF that we have generated. And this is the variable mapping. To just get the variable mapping, we can use option number 13. This is the variable mapping. Now, we can also save the CNF file that we have created, the DIMACS file that we have created into a particular file. Let us use option number 9 for that. We can enter the file name. Let us say that the file name is D. So the DIMACS file would be saved in D file. Let us see. There is a D file. What does it contain? It contains the DIMACS data that we just generated from the CNF. Let us get back to our code. Now, we can also load a DIMACS from a file. Let us try to do that. Let us access option number 10 for that. We can enter a file name. Over here, you see DIMACS file1.cnf. This is a file that I have got from SAT 2002 benchmark data, which has 350 variables and 700 clauses. Let us use this file and load it in our system. How will I do that? Go to the current directory and access the file, which is DIMACS file1.cnf. What do we get? What do we get? We get a message that this particular file is loaded, which contains 350 variables and 700 clauses. We can also display this DIMACS over here. Let us use option number 11 for that. This was the entire DIMACS file, that is this entire content which we have loaded in our system. Now, we can also evaluate this DIMACS formula. If we do that, we'll access option number 12. The code asks, do you want to assign the values automatically? If we press N, then the code will ask the value of each and every variable. So we'll have to write 350 zeros and ones. Instead of doing that, I would like to automatically fill in the values of the variables in the loaded DIMACS file. So I'll choose option number. So I'll write y over here. Now the code will ask, how do you want to assign the variables? I would say assign all the even index literals 0 and rest 1. I'll choose option number 3. For this particular choice, the formula is unsat. That is, the formula values to false. Okay. We can also show the variable mapping. This variable mapping will be shown only for the CNF that we have generated from the binary tree. We can also run a demo. Let us run the demo. This demo takes some small formulae, prints them in CNF form, and converts them to DIMACS. Done, and shows the variable mapping also. We can also display a parse tree from the infix. For that, first we'll need an infix. So let us go back and copy the infix formula that was over here, and we can get back to our code base, and we can access option number 15. We can write the fully parenthesized formula, and that would give us the parse tree. So this was our entire code base that would do various functionalities with various types of propositional logical formulas, which contains many literals and operators, namely the not, and operator, or operator, and the negation operator. Thank you. Bye.